We have uncovered a remarkable planet, a world of extreme weather, alien landscapes, and bizarre phenomena. It's the most complex system we know of in the universe. That planet is Earth, and we are only beginning to unlock its secrets. They are the heartbeat of the ocean, but they have a secret.
It'd be like being hit by a car traveling at 25 miles per hour.
Some can rage out of control.
You've got water flowing into the subways. You've got water at the World Trade Center.
They're called tides. Generated by the celestial pull of a moon and sun, aggravated by weather and land, and wielding the power to trigger some of the deadliest disasters on the planet. On Secrets of the Earth. Even from space, it's clear that one feature separates Earth from all the rest of the planets in this solar system. Over 70% of its surface is covered with water. Where the sea meets the land, the waters rise and fall in predictable patterns known as tides. But closer inspection reveals that sometimes these tides get out of control.
When a tide is coming in slowly at the seashore, it may seem kind of meek, but tides actually have tremendous power.
What makes the gentle heartbeat of the oceans rage in certain places on the planet? Here, in a 50-mile-long inlet off the eastern coast of Canada, tides are taken to their most extreme. This is the Bay of Fundy, home of the highest tides on the planet. A typical high tide is about 2 to 4 feet. But throughout the year, the tides in the Bay of Fundy can rise to over 50 feet, the height of a 5-story building.
115 billion tons of water comes into the Bay of Fundy, and 150 billion tons of water goes out of the Bay of Fundy. To put that in context, the force of the water moving in and out of the Bay of Fundy is equivalent to about 8,000 locomotives pulling that water in and out of the bay.
The sheer load of water moving in and out of the Bay of Fundy actually tilts the province of Nova Scotia back and forth by 1/16 of an inch during each tide cycle. If the energy of these tides could be harnessed, they could generate upwards of 10,000 megawatts of electricity, enough to power over 3 million homes a day. These powerhouse tides not only achieve awesome vertical heights, they also span almost 200 miles of coastline. So when the water retreats, it exposes hundreds of thousands of acres of the ocean floor.
We're at low tide at Alma Harbor. And if this were high tide, I'd be 6 feet underwater. And as the tide continues to go down, I'd be able to walk out for 1 to 2 miles.
But what is the secret that drives these mysterious waters in the Bay of Fundy? All tides on Earth, no matter how extreme, are powered by a force from space.
Tides are mostly caused by the gravitational influence of the moon. and to a lesser extent that of the sun. The moon pulls on the near side of the Earth more than it pulls on the center, causing the near side to bulge out toward the moon a little bit. It also pulls on the center more than on the far side, causing the far side to bulge out from the center. So there are two bulges on either side. This bulge consists of water that's bulging toward the moon and away from the moon, and to a lesser extent, toward the sun and away from the sun.
As the moon revolves around the Earth and the planet orbits the sun, these tidal bulges cause the water to rise and fall, producing high tides and low tides. The tides in the Bay of Fundy begin with the gravitational pull of the moon. But they are taken to the extreme by the bay's unique funnel shape. As it juts in from the sea, the inlet quickly narrows and becomes extremely shallow. When the tide rushes in, the water piles up. But there's another secret that propels these tides to astonishing heights. In addition to the small waves you see crashing on the shore, there is a larger, overall rocking motion in any body of water. In the Bay of Fundy, the time it takes for this large rocking motion to go from the mouth of the bay to shore and back again is around 12 hours. Since ocean tides happen to rise and fall around every 12 hours too, at the precise time the water has rocked back toward the mouth of the bay, another high tide arrives to push it back in. This reinforces the rocking, amplifying the tide upwards to 50 feet.
Not 2 hours ago, the boats were about 15 feet higher at the high tide mark, the high water mark, which is that change in color you can see over there between dark and light. The boats are now sitting on the sea floor.
For hundreds of millions of years, the tides in the Bay of Fundy have chiseled away at sandstone rock to form dramatic coastal structures, like these towering sea stacks that look like gigantic flower pots.
With time, as coastal erosion continues, these sea stacks will essentially collapse and new ones will form.
The tides in the Bay of Fundy not only erode the shoreline, they also have the power to kill. People occasionally find themselves strolling a mile from shore when the tide turns. January 20th, 2012. Two fishermen drowned when searching for lobster traps during low tide in the Bay of Fundy.
Tides in the Bay of Fundy come in at the rate of an inch every minute, so they're incredibly fast. You could potentially be swept away from these strong tidal currents.
The Bay of Fundy may have the highest ocean tides on Earth, but halfway across the planet, a different type of treacherous tide rules the bay. There is a place on Earth where an extreme tide can sometimes be downright vicious. The east coast of China. Here, just south of Shanghai, the waters of the South China Sea surge through the bottleneck-shaped Hangzhou Bay. As water piles up at the narrow mouth of the Qiantang River, the incoming tide forms a long wave of water that barrels up the river against its current, rising to 30 feet tall and moving at 25 miles per hour. It's known as a boar tide. Unlike a normal tide, This tidal phenomenon occurs when a forceful incoming tide creates a wave of water that pushes up a narrowing river or bay against the current.
The standing wave forms because the water that's building up can't dissipate fast enough because the tide's rising so quickly. And in the Qiantang River, the tidal bore is consistently 30 feet high.
The Qiantang River bore tide occurs twice a month when the sun and moon collectively exert their gravitational pull on the Earth.
Twice per month, when we have new moon or full moon, when the sun, moon, and Earth are aligned, the tides raised by the sun add to the tides raised by the moon. So you get exceptionally high tides. These are known as spring tides because they spring forth.
While a full or new moon can produce extra high tides, there's another celestial secret that takes the bore to the extreme. On the 18th day of the 8th lunar month, over 170,000 tourists attend the annual Qiantang River Bore Tide Festival. It coincides with the autumnal equinox, when the center of the sun is on the same plane as the planet's equator, and the gravitational pull is at its peak. That's when the Qiantang River produces the biggest bore on the planet. The frothing beast generates the thundering sound and power of thousands of galloping horses. Even world-class surfers test fate when riding the roaring wave.
They have a tremendous amount of force that in some cases can uproot trees. So it's the force with which these tidal bores move upriver that makes them so dangerous.
Since the tide-watching day began over 2,000 years ago, this extraordinary bore tide has come to be known as the Silver Dragon. Curious spectators are often swept away because they stand too close to the water's edge. In 2011, fierce wind and rain from Typhoon Namadol amplified the bore to an unprecedented 70 feet. It overtook a dam and this unsuspecting reporter. Nearly 20 years earlier in 1993, the Bore Tide Festival claimed 19 lives, the river's worst disaster on record.
The tidal bore traveling at 25 miles per hour, which is typical of the Qiantang River tidal bore, would be like being hit by a car traveling at 25 miles per hour.
While the savage bore tide on the Qiantang River typically occurs once a year, there's another place on the planet where they happen every day. At first glance, the ocean tides on Earth may look like the gentle, rhythmic movement of water. But scientists are discovering the secret to why some tides have a violent streak. Just outside of Anchorage, Alaska, is Turnagain Arm, a branch of Cook Inlet that leads in from the Gulf of Alaska and the Pacific Ocean. Its spectacular waters, bordered by the majestic Chugach Mountains, attract beluga whales, bald eagles, and black bears. But twice each day, a different kind of creature emerges. It's known as the Turnagain Arm Bore Tide, a wild wall of water moving into the bay against the current at 15 miles per hour.
In Turnagain Arm, there's a special set of conditions that make it unique where the boar tides happen every day. In fact, it's the only place in the United States where they do happen on a regular basis.
The secret to forming bores in Turnagain Arm is its narrow, shallow waterway, which connects to Cook Inlet, a much bigger body of water with the largest tidal range in the United States. The difference between low to high tide in Cook Inlet can be as much as 35 feet.
Turnagain Arm itself, because it's connected to the deeper Cook Inlet, when the tide comes in, it's such a mass of water flowing up the inlet that it's got nowhere to go.
At the mouth of Turnagain Arm, the 13-mile channel quickly narrows to 2 miles and then thins out even more over its 40-mile length. This abrupt narrowing causes the incoming tide to form a wave. The crest or highest point of the wave travels at a faster speed than the base of the wave, which causes it to steepen. A large wave front is produced and the bore is brought to life. For some thrill seekers, the lure of a bore tide is too hard to resist.
Kayakers, windsurfers, even regular surfers will try and take advantage of it. But they certainly know the dangers associated with it. The wave has been large enough to take down a moose and submerge it and eventually drown it. So it's definitely not something to be trifled with.
Bore tides hold another deadly secret. As they barrel onto beaches, they deposit mud and other sediments that can hold people in a death grip.
If you ever try to walk out on these tidal flats, you'll quickly see why people really don't do it. The mud is almost the consistency of toothpaste, so you can sink up to your waist. So not appreciating how fast the tides come in and getting stuck can potentially lead to drowning.
Each year, the local fire department near Turnagain Arm makes 6 to 10 rescues of people either trapped in the mud flats or overtaken by the fierce tides.
We've had people that got stuck out there and swept off with the current where we had to pull them off, so there's certainly a lot of risk involved with being in the wrong spot with the tide coming in.
The bore is hardly the only killer tide on the planet. Sometimes, a harmless high tide can be transformed into a monster by a ferocious storm. In some places on Earth, extreme tides are a daily occurrence. But elsewhere on the planet, harsh weather can heighten tide water unexpectedly and turn normally tranquil shorelines into hostile slivers of real estate.
The largest storms, such as hurricanes, typhoons, or cyclones, are such low-pressure weather phenomenon. The less force or the less air pressure you have on the surface of the ocean allows that tidal water to rise up even higher, forming an especially high storm surge.
A storm surge is the abnormal rise of ocean water above the usual high tide. It's churned up in advance of a big storm, like a hurricane or typhoon. A storm surge combined with the water from a normal high tide produces a storm tide. But when the storm surge happens during high tide and a full moon, it's a recipe for a colossal tidal disaster. October 29, 2012. High storm tides generated by Hurricane Sandy battered the mid-Atlantic and northeastern United States.
What made Sandy so devastating was the fact that you coupled this huge storm surge right at the time of high tide. These two things were maximized. So you take this 8-foot storm surge and you put it on top of what is an astronomical high tide. And as we saw, record-setting storm tides in many locations up here.
The storm tide surged to 17 feet in some areas, nearly the height of a 2-story building. The excessive tide water got funneled in and trapped by the low-lying narrow bays, inlets, and islands. In southwest Long Island, storm tides flooded over 2 miles inland. The view from above shows the wrath of the killer storm tide. As of 2012, Sandy is the second costliest hurricane in recorded U.S. history.
The storm tide rolls in, it's going to pick up whatever floats, and unfortunately boats float. In this case, they just pile them all up here.
Around the blue planet, the waters will continue to rage, drawn by the pull of the moon, churned into waves, and unleashed by freak storms.
Going in and out of high tide makes the ocean different for people that are out on the beach enjoying it. But we have to respect the tides.